Okay, so we're making baby steps here. We're making progress. We've got all of our user input validated. We are now able to modify the board, and we're also able to print the board. So we're definitely making progress. The next unit test that we need to focus on passing is finding a winner. That's essentially what we're missing here, is being able to print the winner. And so, I could, for instance, go here and I could print I could hard code no winner. I can't remember if there was a dot or not, a period. And I can run my make test, and well, it'll print that, right? So right now it says no winner. That's actually incorrect. There's two winners. So it's actually an impossible state. We're not going to worry about figuring out if it's actually an impossible state, like all O's or all X's. We're just going to take the board as it is, and in the next version, actually, we should, in the iterative version, in the interactive version, it should never be possible to get to an impossible board. So we need to print out the winner. And so for that, we need to focus on passing this test. And so this one's a little more complicated. If we look at the unit test, we can see what it's trying to do. There are 8 possible winning states. And so what it's doing is it's going to alternate for each player in X and O. And it's going to need to figure out what the other player is. So if it's X, the other player needs to be O. If it's O, then the other player needs to be X. And it's going to go through each one of these boards, each one of these strings, and it's going to replace the P with the given player. Here it's looking to find, it wants to find just 2 other random positions from the ones that are dots. So it finds out which of the cells have where that cell is a dot. And then it's going to randomly sample 2 of those to mutate, and then the board it's going to test is going to be it's going to use all of these for the given player, for the winning player, and it's going to make the other player be in 2 of those other random places. Honestly, this was I wrote this because my students were actually kind of taking some shortcuts, I would say, and so I realized that my test wasn't quite as rigorous as it needed to be. So I needed to interject. I needed to put in there the couple of random positions for the other player. And what I want to assert is that no matter how, as long as there is a winning configuration in there, no matter what else is going on, that find winner for this test that I'm giving is going to return that it is the player who I've determined is a winning player. So we need to do kind of the opposite. We need to figure out, we need to record which of the winning boards kind of do the mirror over here. And what I'm showing, the way that I approached this here, was to create an array, a list of lists where each one of these values is a winning configuration. So what I'm saying here is that if in positions 0, 1, and 2, and I'm using the zero-based indexing now because I'm going to just because I'm not worried about displaying this to the user, and I don't want to worry about subtracting 1 and all that. I'm just going to stick with zero-based arrays. So I know that if given a board, if in positions 0, 1, and 2, all of those are the same value, then that's a winner. Same for 3, 4, 5, 6, 7, 8. Those are your rows. And then 0, 3, 6, 1, 4, 7, and 2, 5, 8 are your columns. And then 0, 4, 8, and 2, 4, 6 are your diagonals. So those are all the places where if those values are all the same, either an X or an O, then that either X or O is the winner. So over here, I'm going to do kind of the opposite thing. First off, I'm going to go through each of the players in X and O. So for player in, and here I'll just do XO, which is essentially the same thing as what I'm doing here. And now I want to go through each of these winning combinations, and I want those values. So these are going to be given to me as a list of lists, and I want to put into I the value 0, into J the value 1, into K the value 2. So I can unpack each one of these sublists into each one of these variables by doing this. So I can say for I, j, k in winning. And, you know, I won't worry about that for the moment. So that's pretty useful to be able to unpack that like that. I wanted to say that I, j, and k, some people would really not like those variable names because they're so very terse and undescriptive. But I is so commonly used for an integer value, so, or n, you know, so for n in some list of numbers, like in a range, n for number, or I for an integer value. Just it's such a common idiom that I think that it's not such a bad variable name. And it's also extremely common that if after I you need a secondary another integer value to go with that, you just use j and then k. I definitely don't like L because it looks so much like the letter 1. So I, j, and k is probably about as high as I would go for this. You could also use, you know, m, n, o or something like that. Kind of taking these ideas from math. And so I think a lot of programmers would not find that to be too off-putting. So what I want to do now is use those values and here I'm creating this variable called combo. So the combination of these cells. Looking at board at I, j, and k, I create this combo, and I'm saying if that combo is the same thing as saying player, 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 then I want to return the player. So what I have done now is I've found a winning combination, and so I'm going to return the player. What happens here if I don't code anything else is that the default value is going to be returned here. If I don't say return, if I never execute this return, then I'll just fall off the end of the function, and the default value will be none, will be returned, which is what we put here, was that we determined that a losing board is going to return none. So at this point, I should probably be able to pass my my unit test. And let's see. Yes, I'm now passing both the winning and the losing boards. So I'm positively identifying the winning boards, and I'm not mistakenly identifying a losing board as winning, at least in the way that I've written it as a test. It's not an exhaustive test. It's not an exhaustive way of doing this, but it basically, you know, it's a pretty decent way of verifying that your program is working. At this point, I'm probably passing almost everything. Looks like I have a little bit more to work out, and so let's take that up in the next video.